that you really care, really. Okay, so this is the second part of chapter 2. We're going to talk about multi-view drawings. How do we choose them? We're going to go through some specifics, not just the terminology, but now we're going to talk about the drawing views. So here's a school bus. Or if you had a die, like you're playing dice, and you take that die and you can rotate it around to all 6 sides. You know, if you take a cube, you got 4 sides, a top and a bottom. So when we're talking about multi-views or multiple views, they're all rotated 90 degrees. We're not talking about looking at the corner of a part or tilting it. Those are other kinds of views that we're going to learn about later. But, you know, when, let's say that somebody gave you this school bus, and if somebody said, what is the front of this bus? What would you call the front view? Most of the people think that it's the looking at the grill of the bus, right? That's what you call the front of the car. It's looking at the windshield. So front is kind of a misnomer. It's kind of the wrong name, but people use this a lot. And the front view could better be described right down here. It says as the principal view. Speaking of view, I'm going to go to this read mode here. Woo. So the principal view, and what does a principal view mean? It means if you had just one view to show anybody, to try and describe when you're talking about this bus, which view would you pick? Bottom view wouldn't be a good one. Top view, maybe not. That could be any kind of truck. Looking at the back of the bus, I could probably get that. But the left or the side view really makes a big difference to me. Because when I can see the doors opening all the way down, I can see the windows at every seat. I can see that that's a school bus. I can also see it here with the stop sign. Now you can see that because it says school bus on the front. But here's another way to think about it. What view could you put most of the location and see most of the features of that vehicle in? Like if I was going to draw this drawing right here, I could get the wheels and tires, I could get the shape of the bus, and all I would have to do to make it 3D is just push that profile right there. I could push that out, however many feet that is, 8 feet, and that would be my bus. I couldn't do that with the right view, with the back view. That's not the same, the gaps here. I wouldn't have this same profile all the way through this. There's a cut here. I'd have to make more cuts. So if you can think about this as a profile of probably the most descriptive view, that if you just pushed it back and gave it thickness, it could almost make the part with that one view. Now, if you were a drafter and somebody gave you a part and said, go measure it and go make a drawing of it, you don't have an input. They're not telling you what view to use first. Imagine it as if you only had one view to draw. What would be the best one to describe it the most you could? A lot of times we're going to, when things have angles or cuts like this, have different heights, have different shapes on them, that's going to be kind of pretty descriptive. Has anybody, Raising Arizona, you seen that movie where I think the guy is going in, he's getting his picture taken to go to jail. And they say, turn to the left, turn to the left, turn to the left. They're getting the profile of his face. That's the most description you could get of someone's face. It's the shape of it. So we're thinking about the profile of this of this school bus. This is a shape. And so if we just push that back in depth, we would almost have this entire school bus done. We could model it with that one sketch and then just push the depth. So this is what we also call the principal view. So this gets, it gets confused with the front of the bus. We call it the front view, just as we would call it the primary view. So let's call this a primary view. This is my primary view. Well, relative to this view, if I touch the right side of that primary view and rotate it around where I'm looking at my finger touching it, in other words, I'm going to rotate it toward me, that would be the right view of the primary. It would be the right side of the primary view. If I touch the left side and rotate that toward me, 90 degrees, that would be the left view of the primary view. Touch the top, rotate it up, and I would be looking at my finger. So a lot of people don't know how to rotate something. They rotate it the wrong way. Imagine actually putting your finger on the top of this bus. You're going to rotate it so that you can see your finger. So you're rotating it always toward you. Now, I cannot get from the primary view all the way to the other side. You cannot skip putting this view in and put this view in. You need to show people how you got and rotated to this view. So if I needed this back view or rear view of our primary, I would have to have the left view and then touch the left side of that, and it would rotate to show the back side of that. Likewise, I could do that on the right of the right view. I could do it over here too, and it would just be flipped in the other direction. And then the bottom view from the primary, I could get here. So from the primary, how many views can we get? I got my primary. I can get 4 views directly projected. And then, so there are 4 views across the primary. That's 5. And then from one of these, either the left or right projection of the primary view, then I have the backside of the primary view. Now, notice that all these views are in alignment. This is the most important thing. They have to be lined up horizontally. They have to be lined up vertically. Because if I drew this right here, and I had this right here, I don't know up here where that ends. I could draw a line straight up from here to here because these views are in alignment. I can use one view to help me project up and down where this wheel starts on here. I can't see that. It's just I would just have a big square. So here's this wheel right here. It starts right there. It goes so deep and it stops right here. So I can actually project geometry if they are in horizontal and vertical alignment. And it's very important to do that because I don't want to remeasure this thing. I don't want to measure, where this one is and then go back and have to remeasure this drawing. I want to simply line these up, and with a vertical rule, absolutely vertical from view to view, I can project that geometry down and draw this a lot quicker. All right, go into the next view or the next sheet. Let me hit page down. That doesn't work too well either. Let me do this. Okay. So here's another way to look at it. If you had a part inside a box and then you turned it around and you traced this part onto each one of these, you could simply unfold this box and have 6 views. And so there would be our primary, the top of the primary, the right of the primary, the left and the back of the primary, and the bottom view. Now you see all these different kinds of lines. These are the line styles that we're going to talk about. So let's talk about those now. Lines. Anything that you can touch, the tangible lines, will be called visible lines. If you can touch them, you better, you can see them, right? So in this orientation of this part, I can touch all these edges. They will be a solid line. And visible lines override everything else. Because let's say that I had an edge right here and it was a solid line and I had this dash line underneath it, it's going to fill in all those dashes anyway. Visible lines are the most important. That's what you can touch in that orientation. All right, so let's go to the next one. And so it's like, which ones override everything else? Visible lines are king daddy. They override everything else. It's the most important. One reason is, and I'm going to tell you this ahead of time, you cannot locate or give a size to anything that you cannot touch in that view. If it is not a solid line, you cannot put the size of that hole or the location of that hole in that drawing, in that view. It has to be where you can touch it to locate it or give it size. All right. The next type of lines, the next in line of hierarchy underneath King Daddy is the prince, I guess, the hidden lines. So who in the world would have thought that you would have to go in and draw everything that you can't touch? It's just more descriptive. So I have hidden lines here. This is as if this solid has a break right here, and this is not solid. And then it has another break. Now, we don't know if this is a hole or a square cut. So you don't put a diameter on a square because it's not a circle that you measure across, right? So we never put a diameter on anything but a complete circle. So this could be a square notch. I don't know. I don't have the part. But that brings me to the next thing. The lowest man on the totem pole is a center line. Now, what does a center line do? We don't dimension to the edges of a circle. We don't dimension to the end of a round like this. We normally are going to dimension to the center. And it looks like a bullseye, right? It looks like a scope. So you have the crosshairs of the scope, and that's this little plus symbol. And then we have gaps all the way around there. And then we have these legs that come out to the end of the largest of the concentric. This hole and this arc have the same center. Because I see that because I have just one center mark. So if I have two concentric things, I don't just stop like this one at the edge of the hole. I go to show that they're concentric. I take this to beyond the largest of the two concentric objects. This one doesn't have anything that's circular that's concentric on it, so it just goes beyond the circle. This one goes beyond the circle, but it's the same center for this. We call this a full round. This is a 180-degree radius. So we go beyond that. And it shows that I'm not only locating the hole, but the radius too. They're concentric. They have the same center. They have the same coincident center point. All right. So that shows, of course, that that's round. But what about in the side view of a hole? I couldn't tell that this is a circular cut except that I have this. And this is called an axial center line. So we have a bullseye or top-down way to show the center line. And we actually dimension to those center lines. Never to this little center point, but these extension lines. Even over here. You see those gaps are maintained around that plus in the middle. So this is an axial center line. It has a straight line and a dash and a straight line. And that's looking at the axis of a cylinder. Could be a cylindrical hole or a cylindrical protrusion. Anything that, I'll tell you the secret to that. When you have a bullseye in another view, where you're showing that, because I cannot put a size notation on this where I can't touch it. These dashed lines means it's hidden. I can't touch that there. We're just showing in this view that there is a void or some feature there. So if I have a bullseye in another view for this hole, anytime you have a bullseye, you better have an axial center line in every other view. It's more descriptive. It's descriptive geometry. And we use lines to do that. So the precedence, King Daddy, visible lines. Prince Daddy, hidden lines. And the lowest man on the totem pole are center lines. So let's say that I have a hidden line and a center line, and they're right on top of each other. You're not going to put the center line. You're going to put the hidden line because that is the edge of solid geometry. Centers are like a fictional bullseye in the center of a hole. I would have to literally go and find where the center of a hole is. I cannot touch it, right? So being able to touch lines or being able to see edges of cut material or steps or edges of solid material is more important than seeing the center lines maybe on the side view of a hole. You will have another view because you have to dimension this. You have to put a size notation and location for this hidden feature in another view. You can never, ever, ever dimension to hidden geometry. So the cool thing about this line precedence is this is exactly how I draw things. I draw my visible lines first. And from those visible lines, I can project from one view to the other the hidden lines. And then the very last thing is I go in and put my center lines in. If there's a hidden line already there and I can't put it over it, then I leave that center line off. This is the order in which I draw those lines. So I draw all views with visible lines first. And then I go back and put hidden lines in all views. And then I put my center lines in. So talking about, yes, you have a question?
So when you go in and make the visible lines, do you put the hidden lines in afterwards to
Yes.
Like straighten it up?
No, you put these hidden lines in because you wouldn't know that this wasn't solid all the way down. Right?
Okay.
This just tells you that there's something inside here. So you better go look at another view to see what it is.
Okay.
Does that make sense?
Kind of, yeah.
Kind of, yeah. It's just more description of this part. If you just had this view and you didn't have any other views, you know there's something going on in the middle of this. I don't even know if this is curved or straight up and down like a block until I have another view of that too.
Okay.
So, yeah. So a lot of times we have to have, like, we'll have a hidden edge on this projected view down here from this one to show that there's a notch or something going on right here, but I can definitely see it in this view. I can touch it. So I'm going to dimension it, put the size and the location of where it starts and its width in this view. Now I'm going to talk about these other lines real quick, but we're going to do that when we get to putting in these notations. Leader lines are arrows that lead the dimension, lead your eyes out away from the view. You can never put any notes like size or location, dimensions or numbers or notes in the body of the view because it can clutter it. Our main objective is to make this as clean and easy to read. And the standard says the more you align things, like lining these up and giving space right here between these and not crowding them, don't let anything touch the object. See these gaps away from here? That makes clarity for whoever has to read it. So one thing that we never do, you see this line right here? This is called a dimension. Dimensions do one of two things. They either locate something or they tell the size. And that is a numeric notation that either locates or tells the size of something. When we put that on a drawing, the lines with the arrowheads that surround that dimension are called dimension lines. Why is that important? We can never cross, like I couldn't pull this 0.375 and have this line cross over a dimension line. That's against a standard. Because if you kept doing that and doing that and doing that, and you couldn't see where you were actually dimensioning to. It's where do you measure from to get to this point, in other words. So keeping this really clean, not overlapping things like that, is the goal. So arranging these things is half the drawing. Okay, so we have leader lines. We have dimension lines. Now, these are also dimension lines on this 0.375. I just like to say they surround the dimension just because that reminds people it's a dimension line. Now, this is a dimension line right here, but this part outside extends this dimension away. There's not enough room to put that inside and have the arrowheads outside, so sometimes we have to flip it. These are called extension lines that extend these away in order to, and this happens in architecture and civil too, in order to keep these things from overlapping, you put usually the smallest dimensions closest and then the overall very last. So you could have multiple rows of dimensions here, and then you just try and line them up so that it's really easy. Even these lined up. Having these things really, really clean and in order, I swear, I'll show you some really hard to read drawings because they're not cleaned up and orderly and aligned, the dimensions aligned. And I've got some cool buttons that are going to help you guys do that. All right, so we've got a certain distance minimum that we have to stay away. We have a certain distance between these two. And every one thereafter, if there were another one and another one. And then this gap has to be a certain distance. So we had to put these rules in order so that we didn't have variations between all different companies. And everybody follows the same standard so that we can read the drawings easily. All right, so I'm going to go on down and we're going to talk about projection planes. But let me go ahead and start another video because this is kind of getting a little bit long. I just wanted to drag this, and I don't think it's letting me do that too easily. Okay, so I'm going to stop this. We're going to start again. Let's see if we have any questions about this so far.